Hello physical science student, today I'll be doing some basic example of displacement for you that requires no need for Pythagorean theorem at all. So with that, let's get going. So pretend here I have an example where Mr. Wu goes 3 feet to the left, 5 feet to the right. What is his total displacement? So to do any displacement, it's always good to draw it out. So pretend I have that question, right? I went 3 to the left, 3 feet to the left, 5 feet to the right. So if I were to draw a graph, I don't need a lot, just maybe 5 or 6 grid, and that should be enough, right? So if I go 3 to the left, that means I need to have at least 3 blocks from where I start to the left, and then 5 to the right. So maybe I want to start, somewhere around here. Doesn't matter. And so if I went 3 left, I go 1, 2, 3. That's in the red. And then I went 5 to the right from there. So that'll be the blue. 1, 2, 3, 4, 5. So my start is here, and my end is here. What is my displacement? What is the arrow from the beginning to the end in a straight line? So the green will represent my displacement. Do I need to use a calculator? Do I need to do anything at all? No, because I know that this was 5 feet in the blue, and this is 3 feet. The 3 is removed from the 5, so the green line is only 2 feet, right? So that's just logical thinking. So my displacement is equal to 2 feet. And which direction was it? I went to the right. Based on the example, I said right, which means east. So that's an example of a simple displacement that requires no Pythagorean theorem. Here's a slightly more complicated one, but you do not use any equation. You just use your common sense and a little bit of adding and subtracting, okay? So pretend I am Mikasa, and I have to deliver some equipment to some people and then get back into the position that I need. So I jump 50 feet forward, 70 feet to the left, and 50 feet backward. So those are my key information. So with that, let's just say if I do 10 feet for every one line, I would need a box that is at most 70 feet or 7 boxes. And then just to give it a little bit extra room, so maybe 8 by 8. So I draw my box. Right. So that's more than enough, right? So I go 50 feet forward, 70 feet to the left, and 50 feet back. So I need to start from the lower right hand corner somewhere. So let's just say I start right here, and I go 50 feet. So I'm just gonna note right here that one of these is equal to 10 feet. Okay, so if I go 50 feet, I go 1, 2, 3, 4, 5. And then I go 70 feet to the left. So 1, 2, 3, 4, 5, 6, 7. And I went 50 feet backward. 1, 2, 3, 4, 5. So this is my end, and this is my start. This is 50 feet, 70 feet, and this is 50 feet. So what is my displacement? Once again, displacement is arrow, which is a vector. Once again, vector represent displacement as well as velocity. That means anything with a number and a direction. So the length is the number, and the direction of the arrow is the direction. So I know whatever my answer is, the displacement is going to be going to the east, right? Because the arrow is clearly pointing to the left, which is east. How far is it? Well, these two cancel out with each other, so I know these two lines right here are the same as each other. So I know this is also 70 feet. So I don't need a calculator or anything like that. I just know that this part cancel out. So this will be displacement equals 70 feet, which is the magnitude, and the direction is to the east. Okay, so that's just an example of simple displacement. You're going to use that logical thinking to do the first problem on the eDoc today, and I'll show you how to do that and log in at the beginning of class on Google Meet.